Let's look at ionic bonds and ionic compounds. So let's say these together. Let's say it together. Ionic bonds, ionic bonds, ionic compounds. One more time, ionic compounds. Good morning, class. So let's go ahead and talk about ionic bonds. So first, let's take a look at these magnets here. When we think of magnets, we know that when we have, for example, let's put an N here for north, two magnets, and south, two different polarities, two different poles, that when we have two different poles, two poles that are alike, they repel. When we have two poles that are opposite, they attract, and thus the magnets would come together. So when we think about basic electrostatics, as we've talked before, like charges repel, opposite charges attract. So when we're talking about ions, we're talking about positive and negative particles. And so it's this force of attraction that creates this bond we call an ionic bond. So it's this force of oppositely charged particles that create this bond that will combine to form, which will combine atoms to form new substances. So again, an ionic bond is formed when we have two or more oppositely charged atoms to form a bond. So let's go ahead and take a look at what we've looked at before. So remembering a quick review here that metals lose electrons. And let's go ahead and state that again here. Metals lose valence electrons. Now, on the opposite end of the spectrum here, we say that nonmetals gain valence electrons. And let's remind ourselves that when metals lose valence electrons, they lose those negative charges, so they become positive, and those positively charged atoms we call cations. And on the opposite end of the spectrum, nonmetals gain valence electrons and they become negatively charged ions, and we call those anions. So here in our quick review, we can see that sodium is a metal. We could look that up on the periodic table. If it loses one valence electron, it will then have a full octet of valence electrons, a full outer energy level of electrons, 8 being the magic number there from what we discussed, just like the noble gases, and thus becoming an ion, a sodium ion with a charge of +1 because it lost that one valence electron. Now, in turn, chlorine is a nonmetal and it wants to gain valence electrons to be stable like the noble gases. And in doing so, we can see down here that once it gains a valence electron, it could come from another atom, another metal atom, but in this case, it's sodium, and it has a full octet. And since it gained one valence electron, it'll have a charge of -1. Now, a bond is going to form. I'm going to put some little dashed lines here. A bond is going to form, and the bond that is going to form is an ionic bond. And that ionic bond is formed because we have two oppositely charged ions, and it's those opposite charges that creates that bond, and sodium will bond with chlorine and become a compound, an ionic compound, sodium chloride. So now we have these two atoms that are now bonding together due to the opposite charges of their ions to form a bond. And I'm put a little dash there to show the bond, or we can write down its formula just as NaCl. And something to note is that the charge of this new compound And again, we call it an ionic compound. And I should say the charge of these formula units, the basic unit for ionic compounds, are neutral. The net charge is 0. So, and that's because the two charges here, the positive one charge and the negative one charge, cancel each other out. So we could rewrite the formula as merely NaCl. We can leave in the charges so we can see that the charges cancel each other out here for this formula unit for this ionic compound. And this is what we're talking about today. So we want to make sure we have an understanding of that. And so why do ionic bonds form? Again, it's what we just stated. Metals tend to lose valence electrons, become ions, cations, and nonmetals tend to gain valence electrons, become anions to become stable, to have that full outer energy level full of valence electrons. And so here we looked at sodium and chlorine. And these two groups will form new compounds. For example, we could take lithium right here, and lithium, if you remember, has one valence electron, and we could take iodine in group 7A that has 1, 2, 3, 4, 5, 6, 7, and we use our Lewis dot notation. Well, if lithium loses that valence electron, then it's stable, and it lost one valence electron, so it has a charge of +1 in its ion form. And when iodine gains a valence electron, it becomes an ion, and it has a -1 charge. And it's this force of attraction of these oppositely charged ions that will form the ionic bond. And we can show that like this here, or we can write its formula. And again, we can see that a +1 charge and a -1 charge, if we look at the total charge, that +1 and a -1, if we add them together, the net charge is 0 for the basic formula unit for these new compounds that form due to ionic bonds. So we need to understand that ionic bonds are formed between metals and nonmetals. And as we go back to our first example here, when sodium loses a valence electron, it becomes a positive cation. That's our metal here. Let's put M for metal. And when chlorine becomes chloride and accepts that valence electron from sodium, it becomes a negatively charged anion. And so ionic bonds are formed again between metals and nonmetals. So if we look here at the periodic table, metals in group 1 will readily form an ionic bond with elements in group 7A, because every element in group 1A, those metals, will lose a valence electron to be stable, and the elements here in 7A are ready to accept it, that valence electron, to become stable, to form, in our example, sodium chloride. And let's make sure we have the charge there, sodium chloride. And this is a brand new compound, an ionic compound. And what holds this ionic compound together? Well, it's that ionic bond. And what is the force that holds that ionic bond? It is a force of attraction between the oppositely charged cations and anions. And we call that an electrostatic force of attraction. So as we move forward, we're going to look at chemical reactions. And in fact, this is a chemical reaction that occurs because sodium is a very volatile, it's a very highly reactive metal in its pure form. Chlorine in its pure form is a poisonous gas. But when they combine and form this ionic bond, they become a totally new compound, sodium chloride, table salt, which is safe for us to eat. Now let's look at chemical reactions with reactants and products. Let's say the words together. Chemical reactions, one more time. Chemical reactions, reactants, and products. So what is a chemical reaction? Well, we can take a look at what we have read about in the previous CK12. If we have sodium, which is a highly reactive metal, and it reacts with chlorine, then that represents our reactant. And when those two elements react, they form an ionic bond, as we mentioned before, and they form a brand new product, sodium chloride, table salt. When we talk about ionic bonds and we talk about ionic compounds are salts, is another name. They're solid substances with high melting points. So they have a strong force of attraction. So I'm going to put an R here for our reactants, and our reactants is here. And our products are here. I'll put a letter P here. And this arrow means yield. And what we need to understand is that the properties, okay, of the reactants here are different than the products that are formed. And so sodium and chlorine, as I mentioned, are very hazardous to us here. Let me type that in. So when we look at the property of sodium chloride, its properties is safe. So again, it's safe for consumption. We put it in our food. But before sodium and chlorine form sodium chloride, when they're in their pure state, we say that sodium is hazardous to us. It reacts violently with water. We're mostly made of water, and chlorine gas is a poisonous gas. So when we talk about reactants and products, reactants is the starting material, and when a reaction occurs, like sodium and chlorine bond together to make an ionic bond, and we have a new compound, sodium chloride, the properties of that product is different than the properties of the reactant. So the statement here, same atoms, new bonds. Well, we can look at another chemical reaction here. Hydrogen is a flammable gas. Oxygen is essential for us to live. When hydrogen and oxygen undergo a reaction, here are reactants, they will form a new product, water, H2O. Here's our product. And so the properties of water is completely different than the properties of hydrogen in its pure form and oxygen in its pure form before they react. And so that's what our takeaway is we want to make sure that we know that when we have our reactants, let's say element A and element B, when they react, a product is formed. And so we can say the product is AB, some compound, and it will have new properties. So the same atoms, but now a new bond, a new substance with new properties.